Good afternoon. I hope there will be more students attend today because this class for everyone. So it should be about 80 students. I think the others will come later. Again, I am recording and I will put the recording to the model. Yesterday, I made introduction lecture and I put the recording there. So if you want, you can check it. Let me to start. One second. Okay, sorry, I muted everyone because of two reasons. One of them is by accident, some of you are opening the voice and we just hear the all voice outside. And the other reason is normally I can hardly understand some accents, and it is harder in I mean online lecture to understand. So to be more efficient, I muted you, but I will just check the messages and I will respond to you. So if you have a question, you can just send me a message, I mean from Zoom, and I can respond to you. I think this will be healthier. Okay, let me to start. Just one second. It's better to make slideshow, but in this case, okay. Okay, in our first lecture, we saw what is an operating system. We saw history of operating systems, so how it is evolved. We also saw see what are the functions of operating systems and what kind of operating systems we are. And also I told you about the types of operating systems. It does not mean that it is only one operating system. Some of them we are not using it anymore. Some of them we are using it, but just we are using also other features of operating systems, like today multi-threading, multi-programming is embedded in multi-processing operating systems. And also network operating systems are again, maybe we can put it, or in network operating systems, we saw peer-to-peer. For example, we are only installing a program and our computers are acting like suitable for peer-to-peer operating systems. So this does not mean that each kind of operating system is only one operating system. I am trying to say that. Okay, so in this course there are so many concepts, but don't worry, this is the previous one and this one is a kind of our introduction lectures. So if you follow the lecture, believe me, you will learn all of them very well. But in the beginning, most of them maybe become confusing for you. But I am here for, I mean, in the lecture and also other times, doesn't matter. You can ask me questions. By the way, I will give a homework related to chapter 1. So I think it will be better for you to understand what kind of questions I may ask and what are the important points, maybe by checking the questions. Okay, let's start. The second chapter is process management. By the way, I am trying to okay. Okay. Even it is the beginning of the lecture, I told this sentence so much. A program in execution is called a process. So process is a kind of instructions that is executing by a CPU. Actually, when a process executing by CPU, our program is running. I mean, think about Google Chrome. Of course, this kind of programs have several processes that running at the same time. So when you press run, actually several programs are running at the same time. But here, the situation is, I'm trying to explain in a simpler way. That's why I am saying when you press the icon of Google Chrome, the necessary files are loading into RAM from hard disk, and that program is becoming a process. So a program in execution, it is called a process, and a process is executing by CPU. And at that time, the files, necessary files, are in RAM or main memory, And while CPU is executing, it means that program is running. For example, I opened now PowerPoint program. This program is running now, okay? So it is a process and it is inside main memory. Okay. So I am putting some images to be more informative for you, like this one, which is explaining the difference between program and process. So program, as you see, it is in disk. I mean, when I say hard disk, actually I am trying to say secondary memory. So secondary memory may be another kind of disk. I mean, maybe it is an external hard disk or something like that, but it is secondary memory. So the main memory that we are putting the data, I mean, always. So we have program, and in previous programming courses or introduction to computer courses, you might see that a program is the combination of data and instructions. Data is actually our variables, this kind of things, the information that we need to just use for that program. And instructions are actually the things that it is directing, give some directives. I mean, think about a robot. You want to just want to move it from one place to another place. So you have to say it go straight, turn right, turn left, or think about that your friend is coming to visit you and you need to just give some instructions to find your home. So this is instruction. So programming consists of data and instructions, and it is located into disk or hard disk or secondary memory. And when it is becoming process, when it is loaded into memory from hard disk. So when it is loaded into memory, it is becoming a process. So inside the memory, a program is a process. So it means it is ready for execution. When it is started to execute, when CPU pick that process. And inside the memory, it has other types: data, instructions, heap, and stack. We will see them later. So just know that when it is loaded into memory, it is becoming a process. Okay. In order to accomplish this task, a process needs computer resources. So there may exist more than one process in the system, which may require some resource at the same time. I mean, computer resources is something like that. And think about that. You have to write something, but you are two people, you are with your friend, but you have only one pencil. So your friend needs to write something, you have to write something. So you are two people, two person, but you have only one pen, so or pencil. If the pencil is your resource, you should make a kind of synchronization to just arrange this thing. For example, think about that you are watching something on TV and you need to write immediately. So you can pick the pencil from him and write it. Maybe he is writing, how can I say? He took lecture notes of another friend and he just need to take that notes. So his situation is not urgent like you. So operating system similarly has to manage all the processes and the resources in a convenient and efficient way. So operating system is also doing this. So in computers, different resources, let's say, I mean, any kind of device can be a resource. For example, you have to print something. So at the same time, it is not possible to do it. So if two process has to print something, one of them should wait the other. So according to some rules, operating system is deciding which one should be first. So in the image again here, processor, input, output devices, main memory can be counted as computer resources. So operating system is managing them. But in some case, some resources may need to be executed by one process at one time to maintain consistency. Otherwise, the system can become inconsistent and the deadlock may occur. So the order of the process, the synchronization is very important. Otherwise, some error may occur or some inconsistency may occur, and at the end, a deadlock may occur. I explained deadlock before. Actually, here in the example, you can see it. Think about that. These two guys are processes, and these two tools are the resources. So think about that. This one is using this, but also it is waiting for this one. And this one is using this, and it is waiting for this one. So in this kind of situation, because of both of them is waiting for each other, so a kind of deadlock may occur. So if two processes or more than two processes are waiting for, I mean, to go further, waiting for another resource from a process, but still the other processes are waiting from them. So it may become a deadlock. And deadlock, a kind of situation that your computer is locked, you can't do anything, and eventually you say, okay, I will restart you and start over. So this is called deadlock. Okay, the operating system is responsible for the following activities in connection with process management. So in process management, or it is connected with process management, one of them is scheduling processes and threads on the CPUs. Threads are, how can I say, running more than one process at the same time. It is from, we can just count as same or similar. I will explain it later, but for now, just think that it is a kind of expanded version of process. So scheduling processes and threads on the CPUs. So deciding which process will run, will execute next, or which one will be take out for an input-output operation or something like that. All of them are related to scheduling. Also, actually, only we can say, because in the others it is explaining, scheduling which process will execute next, or which processes will be executed. Into creating and deleting both user and system processes. So why we need to create, or why we need to delete? For example, creating a new process occurs when, for example, you press an icon to run a program. So a process will be created, actually. And deleting a process, when process is finished execution, we don't need to put it into RAM anymore, so we have to delete it. So operating system is also responsible from that. Suspending and resuming processes. This is actually in first part, I told you, when, for example, when a process, while it is executing, when it needs an input-output operation to run CPU efficiently, I told you before that CPU should be always busy. So instead of waiting that process until finish that input-output operation, we can take another process. CPU can take another process. So here, that process will be suspended. It will be just take away. And what is resuming? When it finish the input-output operation, we can put it again in ready queue. I mean, ready queue is inside RAM. So we'll put it again inside RAM to wait its turn. So this is also task of operating system in connection with process management. Also, providing mechanisms for process synchronization. Process synchronization means, think about that. you have one process that, let's say, we have three processes: process 1, process 2, process 3. If, for example, process 1 is waiting some information from process 2, in this case, process 2 should be run first. Otherwise, if you run process 1 and not run process 2, process 1 will wait that information forever, because who will run it and give the results to you? So it is something like that. For example, in business places, for example, your boss is asking you, okay, did you finish the reports of this week, let's say, and you say to him, no, because I am waiting the data from Hassan, for example. So it means that without the data coming to you, you can't finish the reports. So it is something like that. So no one may expect from you to finish the reports without taking that information, because it will be nonsense. So this is process synchronization. So first of all, the previous one should be do whatever it has to do, and then the other continue. 5, providing mechanisms for process communication. Process communication is processes may communicate if they need to just use some resource from that one or something like that. So operating system should also do it. Okay. So till now, we just make generic explanations. That's why I am saying you it will be more meaningful later. From now on, we will start to see the operating system's features in more detail. Okay, the attributes of a process. The attributes of the process are used by the operating system to create the process control block for each of them. Here, process control block is very important, because think about that. This process control block is just having all informations about the process. So think about a kind of scenario that CPU is executing a process, but a process needs some input-output operation. So someone should say where that process is stopped. I mean, like while you are reading a book, you have to remember which page you stopped, because after that you have to continue from that page. So it is something like that. It is just having all information, process control block. So and there are some attributes of process control block. These are just generic attributes, and in operating systems, it may change, or some of them may be much more complicated. But to learn the generic logic, I will explain this part to you. Okay. The first one of process control block, let me to tell you again, process control block is a kind of data structure that holding all the information related to a process. Okay, so in this case, the CPU or other devices can understand what they should do. Okay, so it is like your records that, for example, school records that it is helping to just administrative people to decide what they do with that. So process ID is like our ID number. Each process, when they are created, they have an ID number. And it is, of course, unique. Like our ID numbers. For example, your student ID are unique, or the ID, passport ID is unique. So when a process is created, a unique ID is assigned to the process, which is used for the unique identification of the process in the system. So by checking this ID, the devices can understand, or operating system can understand, which process we are talking about. The first one is that. The other one is program counter. The program counter stores the address of the last instruction of the process on which the process was suspended. So the address of last instruction, it is saving the address of last instruction. Think about that. This is an example that I say, okay, you stop at page 45 and in this line. So after that, you can continue from that. So program counter is doing similar thing. Think about that execution. A program is reading a book. If you make an analogy, we are saving exact page number. Of course, we stop in which sentence or in which letter very precisely. So CPU uses the address when the execution of the process is resumed. So CPU, when that process is start to execute again, it will continue from that place. So this is done by program counter. Process states, the process from its creation to its completion goes through various states, which are new, ready, running, waiting, these kind of things. So the states of the processes is also saving here. So system can understand which state in this process. I mean, if it is waiting state, and it will just, how can I say, put into ready state, it will change in this data structure. priority, every process has its own priority. We will see some algorithms, I think next lecture, next week, which according to that algorithms, CPU is making okay, we have some algorithms because of to make process management and CPU scheduling, and some processes have priority. So priority is something like that. Think about that a scenario. You are in a barber shop and your barber is taking you according to your order. It is a kind of first come, first served. If it is your turn, he will take you to cut your hair. But when I was a child, we had a barber in our village, because, for example, I am waiting for my turn, and I am waiting. He is cutting hair of one person. After that, he will take to me. But then one person comes into the barber shop and says, okay, I have to go in 30 minutes to somewhere else. I don't have time, something like that. And my barber starts to say, okay, you wait. He's saying to me, wait a little bit, I will take this guy and then you. So it is a kind of priority. Okay, so in the processes also have this kind of situations. Okay, I know we have 1 minute. Okay, I will just close the meeting, give 10 minutes break, and after that I will continue.